Hello everyone, in this video we will understand another numerical based on the first come first serve CPU scheduling algorithm. We have seen already two numerical based on this algorithm. You can watch those videos in the operating system playlist. Okay, so let's see this numerical. So here you can see we are given various processes, 5 processes with their arrival time and with their CPU burst time, that how much time they are taking on the CPU. And we have to apply the FCFS algorithm on the set of processes. And based on that, we have to find all these things. We have to draw the Gantt chart, then we have to find the CPU utilization and all these metrics. Okay, so first we have to draw the Gantt chart, and on the basis of those Gantt chart, we can find all these things. So let's draw the Gantt chart. So FCFS algo says that whichever process has arrived inside the ready queue, first it will be given the CPU first. Then whichever process is coming next inside the ready queue, it will be given the CPU next time, right? So here you can see for the first time which process has arrived inside the ready queue. So here you can see this is the lower arrival time, okay, or you can say this is the least arrival time, right? So at t equal to 1, the process P3 has arrived inside the ready queue. I can just draw here ready queue, right? So inside ready queue your P3 has arrived, okay, and let's say this is your CPU, okay. So I will draw the Gantt chart. So here P3 has arrived, okay. So P3 arrived inside the ready queue at t equal to 1, okay. So this is the 1, okay. Now this is taking 2 unit of time on the CPU, okay. So P3 went on the CPU, okay, here, and it was running for t equal to 1, then t equal to 2, okay. So it took how much time? So it took like from 1 to 2, it was 1 unit of time. Then at t equal to 3, it was 2 unit of time. So at t equal to 3, the completion of the P3 will be done, okay. So 1 plus 2, it will be 3, right? Now this P3 is out from the CPU, okay. Now it is no more in the system. Now what is the next process that can come inside the ready queue? So till t equal to 3, that is currently the current time is t equal to 3. So at t equal to 3, which process can come? So here you can see at t equal to 3, this process has come, okay. After P3, P1 has arrived at t equal to 3 only, right? So P1 has arrived inside the ready queue, okay. So now it will run, okay. So I will give this P1 here, okay, on the CPU. So it will run, and for how much time it will run? So it will run for 4 unit, okay. So 3 plus 4, it will be 7, okay. So at 7, this P1 will also be completed, okay. So it will also be completed, right? Now when the current time is 7, then what are the various processes that has arrived inside the ready queue? So here you can see P3 arrived at t equal to 5, P4 also arrived at t equal to 5, and P5 arrived at t equal to 4. That means after 3, at 4 unit, at 4 time, this P5 came. Then at t equal to 5, P4 and P2 came, okay. So here we have many processes, okay. So from 5 and 4, what is the least number? It is 4. So P5 came at t equal to 4. Then P2 and P4 both arrive at the same time, okay. So what will be the order of the processes inside this ready queue according to the FCFS algorithm? So as I said in the previous video also, the FCFS algorithm says if two processes, let's say they are coming at the same time, then you have to break the tie based on their PIDs, process IDs. So this P2 is having lower PID. So you can see this number is telling me the ID number, okay, 2, and this 4 is the PID of this process number 4. So out of 2 and 4, 2 is the least number, okay. So this is the lower PID and P4 is the higher PID. So 5 and 5 are same. So P2, this is the lower PID, it will be given the CPU first. So I can just place P2 here first, and then I can place P4, okay. So first I will be giving the CPU to P5. So P5 will be running here, okay. So P5 will be running here, and P5 will run for 3 units. So 7 plus 3, you can say 7 plus 3, 10, okay. Now P5 is over. Now P2 will be given the CPU, so P2 will run. Okay, so at t equal to 10, P2 will start to run on the CPU, and P2 is taking how much time? 3 units. So 10 plus 3, 13. Right? Now this P2 is over. Now P4 will be going to the CPU. Okay, and it will start at t equal to 13, and it will take how much time? So you can see P4 is taking only 1 unit of time. So 13 plus 1, 14. So this will be P4. Okay, so at t equal to 14, all the processes have been completed. Okay, from P1 to P4. So if I ask you what is the completion time of the various processes, so P1 completed at 7, P2 completed at 13. Okay, P3 completed at this 3, and P4 completed at 14, and lastly P5 completed at 10. Okay, so these are the completion time of the various process. Now let's find the CPU utilization percentage. Okay, so CPU utilization percentage, as we have seen in the previous video, it is equal to like the total time for the completion of the all the processes, or how much time all the processes have taken for the completion from here to here. This will come in the denominator. Okay, and from this total time, for how much time the CPU was busy in doing the useful work, so it was busy at all the time. Okay, there is no idle time. Okay, so here it will be CPU utilization. Okay, into 100, it will give me the CPU utilization percentage. So total time will be 14 minus 1. 14 minus 1. Okay, it is like 13. This is the length of this total cycle. And what is the CPU utilization? So for how much times the CPU was utilized, it will be in units, or it will be in like seconds, something like that. Okay, so from here to here, for all the period of time, 14 minus 1, 13. For 13 unit of time, CPU was busy. Okay, so it will again be 13 into 100. So it is like 13 upon 13 into 100. So it is like 100%, because this is like 100%. So CPU utilization is 100%. There is no idle time in this Gantt chart, or you can say for all these processes. Okay, so this is like very good. For 100% of time it is getting utilized, but it is not in the real case. Okay, in the real example, or in our real computers, the CPU cannot be utilized like for 100% of time. Okay, there are many things involved, like context switch and other things that we will be seeing in the next video or in the upcoming videos. Okay, due to that, the CPU utilization cannot be 100%. Okay, so now let's see how we can calculate the turnaround time. So turnaround time, as you know, it is completion time minus arrival time. Okay, so let's find for P1. So the completion time of P1 is 7. Okay, 7 minus, it arrived inside the ready queue at 3 here. So 7 minus 3, it will be 4. Okay, for P2, the completion time will be 13, arrived at 5. So 13 minus 5, it will be 8. For P3, the completion time is 3, and it arrived at 1. So 3 minus 1, it will be 2. Okay, this one gap. Now for P4, it completed at 14, arrived at 5. So 14 minus 5. So it will be 9. Okay, and lastly for P5, you can say the completion time is 10, arrived at 4. 10 minus 4, it is 6. Okay, now to find the average turnaround time, you have to find the sum of all these things, 4 plus 8 plus 2 plus 9 plus 6. So it will be 29. Okay, you can just find the sum and divide it by total number of processes. So total we have 5 processes. Okay, so it will be you can say 5 5s are 25, and then 5 8s are 40, 5.8. Okay, now let's find the next thing, that is waiting time. So waiting time is turnaround time minus burst time, or you can say the waiting time is the time that is spent by a process inside the ready queue. Okay, so let's calculate for the P1. So here you can see the turnaround time for P1 is 4 minus, what is the burst time or the CPU burst time for P1? It is 4, that is 0. That means the process number P1, it has not spent any time inside the ready queue. Okay, it got the CPU as soon as it arrived inside the ready queue, and it did not wait. And from Gantt chart also you can find the same thing. How? See, P1 arrived at t equal to 3. That means at this time. and it got the CPU at this time only, right? So that means it did not wait any time for the CPU, okay, inside the ready queue. So waiting time is 0. That's we are getting here. Now for P2, the turnaround time is 8, okay, and the burst time is 3, that is 5, okay. So from here also you can see that P2 arrived at 5, something like here, okay, and it got the CPU at this, okay, and for this amount of time it waited inside the ready queue. P2 waited, right? So this will be 10 minus, what is the arrival time? 5. So 10 minus 5, 5. Again you are getting the same thing, okay. So you can also say 10 minus 5. Now let's find for P3. So turnaround time for P3 is 2 and the CPU burst time is 2. That means waiting time is 0. So here also you can see P3 arrived at 1, it got the CPU at 1, so waiting time is 0, okay. Now for P4, turnaround time is 9, burst time is, here you can see it is 1, that is for 8 unit of time P4 waited. So here also you can see P4 got the CPU here and the arrival time is 5, something like here. So for this period, okay, 13 minus 5 it waited. So 13 minus 5 is actually 8, okay. So this is the 8 unit for which it was waiting inside the ready queue. P4 was waiting. Again we got the same thing from this formula also, okay. Now lastly P5, okay. So turnaround time is 6 and the CPU burst time is 3. So 6 minus 3 is 3. And the same thing you can find from here. P4 get the CPU here and it came inside the ready queue at 4, something like here. So for this time P5 was waiting inside the ready queue. So this is like 7 minus 4. It is how much? 3. And this is also 3. So for 3 unit of time, the P5 was waiting inside the ready queue. Okay. Now let's find the average waiting time. So average will be the sum. So 0 plus 5 plus 8 plus 3. So 5 plus 8, it will be 13. 13 plus 3 will be 16. Okay. And divided by total number of process, that is 5. So it will be 5 3 are 15 and then 1, 5 2 are 10. Average waiting time for a particular process or average time for process or for any process, it can be 3.2 unit. Okay. On an average, a process waited for 3.2 inside the ready queue. Now next, let's find the throughput. So throughput is number of processes completed per unit of time. So for this, we can say that what is the total time? So this is the total time. 14 minus 1, it is 13. And how many processes have been completed in this total time? Total 5 processes have been completed. So 5 on 13. So it will be something like 0.384. Okay. So you can say in 1 unit of time, 0.38 process is getting completed when we apply the FCFS scheduling algorithm. Okay. Now let's find the last thing, that is the response time. Okay. So response time is the time which has been taken by a process to get the CPU for the first time from the time it arrived inside the ready queue. Okay. So for P1, what is the response time? So it came inside the ready queue at 3 and it got the CPU at 3 only. So it will be like 3 minus 3, it will be 0. Okay. Now for P2, what is the response time? So P2 came inside the ready queue at 5. It got the CPU at 10. Okay. So for how much time it waited inside the ready queue to get the CPU for the first time? So it is like 10, that is this, minus 5. It will be 5. Okay. So you will see that in case of FCFS algorithm or for any non-preemptive algorithm, the response time is actually the waiting time, or you can say response time is equal to waiting time. Okay. That's why we are getting the same values as the waiting time. Now for P3, you can see P3 came inside the ready queue at 1, got the CPU at 1. Okay. So for this, response time will be 0. Now for P4, came inside the ready queue at 5, got the CPU at 13. So 13 minus 5. 13 minus 5. So it will be 8. Here also you can see the waiting time was 8. And lastly, for P5 came at 4, got the CPU at 7. So 7 minus 4. For this amount of time, it was waiting inside the ready queue to get the CPU for the first time. 3, it is again 3. Okay. So on the same line, the average response time will be the same. This one answer, that is 16 by 5. 16 by 5. Okay. So it will be 3.2. So here one important point to note is, here you can see the arrival time. The first arrival time is 1. Okay. No process has come at t equal to 0. So what you can do is, if you want to just draw this Gantt chart in this way, something like at t equal to 0, there was no process. So you can say from t equal to 0 to t equal to 1, the CPU was idle. In this way also, you can just draw. Okay. And after that, at t equal to 1, the first process came and you can just carry on. Okay. But you have to make sure that you will not take this as the idle time. You will not take this as the idle time for calculating the CPU utilization percentage. Why? Because according to this table, our first process has come inside the ready queue at t equal to 1. So we will do all the calculation starting from this point only. Okay, this is just for the illustration purposes that we have just shown that here the CPU was idle, but we will calculate everything from t equal to 1 only when the process arrived inside the ready queue for the first time. Okay, from the first process only. Okay, so this was just a small thing that you can just draw it, or you can just ignore this part. Okay, so I hope you have understood that how we have calculated all the matrices. So if you have any question regarding any of the thing mentioned here, you can write down into the comment box. And if you like this video, please like and share this video and subscribe the channel and press the bell icon for further notification, and share this video among your friends also. So see you in the next video with next questions. Till then, goodbye.